This is AP Calculus Unit 6 Pretest Fix-Up. This is going to be the solutions. So in this first problem we have a line tangent that we have to find. So what is that going to look like? It's going to be, well, normally it would be y minus something, but so normally we have an equation y equals something with x, but in this case we have capital T is equal to something with lowercase t in terms of this equation, because you can see that we have capital T is our main thing, our main variable, and then lowercase t is what's over here. So we're going to be left with something that looks like this, capital T minus the capital T coordinate. Maybe I should make these boxes bigger. I think we're going to need bigger boxes for bigger numbers. And that's going to equal our slope, which we'll eventually find out, times lowercase t minus whatever t coordinate we decide to put in here for lowercase t. And what does it tell us? So at time t equals 0, the temperature is 180 degrees. So we're using that information, and capital T is the temperature, and then lowercase t is the time. So and then we can plug those in too. So at time equals 0, so at time equals 0, we have 180 degrees, 180, that's our coordinate point, and somehow we have to be able to find the slope, and we don't have the slope, so we have to use this equation here. When we plug in our capital T, we know that capital T is 180 degrees Fahrenheit, so we can plug that in here and we get that d capital T of d lowercase t, our slope, is equal to -1/2, just rewriting it, times, and then our capital T in this case is going to be 180, so I'm subbing in 180 minus 100, and simplifying this is going to be 80, and then half of 80 is 40, so this is going to equal to -40 for our rate of change with respect to time, which means we have our slope. We have our slope as -40. And from there we have our equation. So now we need to approximate the temperature of the coffee after 45 seconds. So after having our equation, now we're going to approximate using the equation. We're going to try t equals 0.75 and see what happens. So just rewriting this equation, coming down here, we have t minus 180 is equal to our -40 times t. Oh, it's not a t anymore. We know what t is going to be. This is going to be 0.75. And I could write -0 if I wanted, but I'm just going to leave it like this. Perfect. Now I need to find what that temperature will be if I approximate using this linear equation. So I need to do 40 times 0.75, and our 0.75 is really 3/4. I don't know why that looks like a 9, 3/4. And I need to multiply that by 40, and you'll notice that the 4 and 4 here cancels out, and it's just a 10 here now. So 3 times 10 is 30. This whole thing is -30. And I'm going to add this 180 over here, plus 180 for our capital T. Therefore, our approximation for our temperature is about 150 degrees Fahrenheit, because it gave us degrees Fahrenheit in our final answer, or in our problem. So that should be our final answer, 150 degrees Fahrenheit. And how do you score this problem? So there's 2 points you can get. The first one is the hard part, knowing that you have to get this equation. So you have to have 0, 180, -40. Those three things need to be somewhere in here. Maybe you distributed or something, but that is 1 point if you get the equation correct. And you get your second point if you get the approximation correct of 150 degrees Fahrenheit. And that plus looks a little bit bad. Let me make that nice and neat. +1 there. And on to part B. So now we're finding the second derivative, and this one is going to be tricky. I know that there was a problem similar to this on the pretest, and this one I'm going to spend a little bit more time on because I think that my explanation for the pretest did not go over very well. So I have my first derivative. This is kind of like our t prime is equal to this thing. So I need to find the second derivative. I'm looking for t double prime. That's what this thing is. Okay, so if t prime is 1/2, -1/2, capital T minus 100, then I need to take the derivative of all of this with respect to lowercase t. So let's do that. I'm going to do this kind of straightforward. I'm going to go ahead and distribute this to make it a little bit easier. So this is going to be the same thing as -t/2 plus 50. And then when I go ahead and take the derivative of this thing with respect to lowercase t, this is what I get. I get t double prime, and t double prime is really just dt of this thing, right? We're just taking the derivative of this thing. So -t, okay, I should make my parentheses a little bit bigger. -t/2 plus 50 and that's going to equal what? So I have d of this dt, and you might think, oh, well, this is just going to be negative a half. That's not quite right. This is really saying it's d negative dt over d lowercase t. I'm just kind of distributing this d dt into this term. And so I have the negative, and then all of that is times a half, I guess. That's where the 2 went. And then I need to add this to 50, and that's just 0. Derivative of 50 is a constant. So I'm left with this thing. So I'm really saying, if I wrote this a different way, this is negative 1/2 times this dt, d capital T over d lowercase t. And we're given this. We know what d capital T, d lowercase t is. It's this thing right here. So this is now turning into, just subbing in for d capital T over d lowercase t, is negative 1/2 of this. And that's going to be, I forgot my 1/2 again. So I have another negative 1/2, another parenthesis, t minus 100, double parenthesis here. All right, so that is the second derivative. And now we need to find if that's an underestimate or an overestimate at t equals 0.75. So how do we do that? I think the best thing to do is to simplify this a little bit. So that is going to be the same thing as positive 1/4 of capital T minus 100. And that, again, can be simplified even more by distributing the 1/4. So it's going to be capital T over 4 minus 25. And before I jump too far into the second derivative test, I need to come back and talk about this guy. I feel like a lot of students will probably dismiss this and say, okay, well, that kind of makes sense because you're just taking d dt and then there's a capital T and somehow you kind of distribute those and get this. So really what you need to pay attention to is this lowercase t and capital T are different. Whenever these are different, you always have to leave it in this form. It's very similar to why when we do implicit differentiation, when you have a, say you have like a y x plus y, and you're taking the derivative of all of this stuff with respect to x. We never actually said that we were taking it with respect to x. When we're taking the derivative implicitly, we're actually taking d dx of all of this stuff, which is why this thing becomes, you still get a y prime out of this. So this would be y plus xy prime. This is really saying, and then you get plus y prime over here. This is really saying a y plus x dy dx. Because we're taking everything with respect to dx, this dy, or this y, is still there. The derivative of the y is still there. Very similar to this. The x doesn't go, or the capital T doesn't go away because you're taking it with respect to lowercase t. When it's with respect to a different variable, you have to leave it like this form until you can find out what that thing is. And we are able to find that out because we have it over here. All right, so now that that is taken care of, I want to go ahead and continue with the second derivative test. So just treat this as a normal second derivative test. Okay, where is this thing concave up? Where is it concave down? So if I come over here and make my number line, I guess I need to set this equal to 0 to see where my possible inflection points are going to be. So I can do that right here. If I say t over 4 minus 25 set equal to 0, add 25 to both sides, multiply by 4, and t is equal to 100. And now I can make my number line 100. If I look at this equation and I plug in, I don't know, something over here, let's plug in 0. If I plug in 0, this is going to be 0 over 4 minus 25. This is going to be a negative. Plug in something bigger than 100. Let's try 200. If I plug in 200, that's going to be 200 divided by 4, which is 8. 8 minus 25 is also a negative. Wait, something is wrong there. Sorry, 200 divided by 4. That was incorrect. 200 divided by 4, Mr. Sandel, is 50, not 8. 50 minus 25 is 25, and therefore this is positive. I was wondering what happened there. This should go from negative to positive. Okay, so now that we have a positive, where are we talking about? Are we talking about this side or this side for this problem? So remember, it said t, lowercase t is equal to 0.75, and we don't have lowercase t, we have capital T. Well, where was lowercase t of 0.75? 45 minutes. So at 45 minutes, remember, we're getting around 150 degrees Fahrenheit for a capital T. We were over 100. So we can say that if we're over 100, we are going to be concave up. So this is concave up. So for all t, so for t greater than 100, concave up. And concave up means that it is an approximation. So under, or an underestimate. Under approximation is still the same thing. Underestimate. I'm just trying to use estimate, the same words that are used in the problem. Is it underestimate or overestimate? So concave up, and that implies it's an underestimate. All right, so this problem is going to be worth 2 points. There's going to be 1 point if you were able to find the second derivative. So 1 point if you're able to find this guy here. You could have left it unsimplified, but second derivative is 1 point. And another point if you're able to say that because it's concave up for this area for capital T, it's an underestimate. So getting that conclusion right is another point. And finally, on to part C for that first problem. So now we're actually doing the particular solution. We're doing steps 1 through 3. Step 4 is that extra credit step that I'll be going through, not at the end of the video, but just at the end of this problem, just really quickly. So here we go. Part 1, this is separate, and I need a lot of room for this one if I'm going through step 4. So separate, right now I have a fraction equal to a kind of fraction. Let's make this, we'll leave the negative there, but this is going to be over 2. So it's going to be equal to, we'll leave the negative on the top. How about? So when we cross multiply, dt times 2. So I'm going to get 2d capital T, and that's going to be equal to, and then I'm going to distribute, so it's going to be capital T minus 100, and all of that is times a negative, so it's going to be negative and a positive. All of that is going to be multiplied by d lowercase t. Okay, you'll notice that I have a capital T on the right, but capital T's need to be on the left, so I'm going to go ahead and divide both sides by negative t plus 100, and this is going to be 2 divided by, we'll change this to 100 minus t to make it look nicer. D capital T is equal to, just nothing over here, d lowercase t. Okay, we separated the variables correctly. On to step number 2. For step 2, we need to integrate. So integrating both of these, integrate the left. I don't like fractions, so I anti-quotient it by bringing this denominator up to the numerator and making it to the power of -1. So it's going to be a 2 times 100 minus capital T, all of this to the power of -1. And don't forget our d capital T, and that's going to be equal to the integral of, we can say a 1 dt there if you don't like not having a 1. All right, so now we have to go on the left. Do we need to use taxman or u substitution? So looking at dinner is 1. Therefore, we do need to use it. So we need a u, we need a taxman, and we need the du, the derivative of u. Okay, u is 100 minus t. The taxman is knocking at the front door. He's a 2. And du is -1. So our fraction here is 2 over -1, which becomes -2. So pay the taxman, let's do that. It's going to be -2, and then I do the derivative of this thing. So I would normally go up a power. This would go to the power of 0. Therefore, I'm using the natural logarithm because I can't divide by 0. So this is going to be the natural logarithm of absolute value. Again, don't ever forget your absolute value. You will lose points if you forget it. This is going to be 100 minus capital T, and absolute value is going to be equal to, then I need to take the derivative of the right-hand side. And that is going to be, whenever I have just a constant, it's going to be that constant times whatever variable I was differentiating with respect to or integrating with respect to. So this is going to be lowercase t, and don't forget your plus c, your constant of integration. Perfect. And then step 3, I think I can squeeze it in right here. Step 3 is to evaluate. And if you evaluate, that means that we will have, what are we evaluating? Okay, so this is our lowercase t and this is our capital T. So when we plug those in, I get a -2 natural log of absolute value. 100 minus capital T was 180. And absolute value is equal to lowercase t, oh, it's not lowercase t anymore, it's a 0 plus c. Perfect, so you got points there. Let's mark up all the points that we just got. We got 1 point for separating the variables. We get 1 point for doing all of this to get the correct antiderivative of both sides. So up until here, this including the t, that's all plus 1 if you got to here. Plus 1 for the constant of integration, you always get a plus 1 there. And if you plug them in at all, you get another plus 1. And you'll notice that we got 4 points before, so we had 1, 2, 3, 4 points, and this is another 4, so we have a total of 8. How do you get that last point? You don't need to. It's extra credit. You can go ahead and skip ahead to number 2, but I'm going to go ahead and solve it right here just in case you're interested in how to do this optional 4th step, which is to separate. Separate. All right, so when I separate, I don't actually want to evaluate in right here because that's kind of a stupid spot, in my opinion, to do it. It might be possible. I don't know of any tricks to get this one undone. So I'm going to leave it in this form, and I'm going to try to undo this natural logarithm, undo this absolute value, so I can try to sort some things out. By doing that, I need to first get rid of this -2. I bring it to the other side, and I get the natural logarithm of the absolute value of 100 minus capital T, and absolute value is going to equal, and I divide everything by -2, so this is going to be lowercase t divided by -2, and then this is going to be minus, or I guess, yeah, it's going to be minus c over 2. I was going to say plus a negative. I think this makes more sense. Okay, so now I need to get rid of the natural logarithm. The way that you do that is by exponentiating both sides. So I guess this is kind of what it looks like. I'm doing it in red here. Maybe I should just do it in black. That would make more sense. So it's e to the power of all of this is equal to e to the power of all of this. And then you'll notice that e and natural log, they cancel each other out. And I'm just left with the absolute value of 100 minus t, and absolute value is equal to all of this. It's the exponentiated form of the right-hand side, which is a negative t over 2 minus c over 2. Okay, the next thing I need to get rid of is absolute value. That's another pesc, so I can do that by doing 100 minus capital T, and the right-hand side now is a plus or minus version of everything here. And I'm going to also switch these, well, I think, yeah, I'm just going to do one step at a time. I'm going to do e to the power of negative t over 2, and I'm going to multiply this by e to the negative c over 2. And this is just rules of exponents. You're allowed to separate them into their bases. You might want to use rules of exponents to make this into a quotient, into a fraction, but it's better in this form. This is the trick. All right, so I'm almost there. I need to find t by itself. So I'm going to do this in 2 steps. I did it in 1 step before in my previous videos. I think it might have been too confusing. I'm going to subtract 100. So I have a negative t is equal to a negative 100, and then that's going to be added to, this is going to be weird, I'm going to add this negative 100 to this plus or minus e to the, and here I'm going to switch these. These two, you can switch them. This is the, oh man, the associative property of multiplication. I think that's what it's called. No, it's commutative property of multiplication. Commute means I can switch. It doesn't matter the name. I'm just trying to impress you. I don't know, trying to make sure I remember. E to the negative t over 2. I just switched them. Okay. And finally, I multiply everything by a negative. So now this is going to be t is equal to now a positive 100, and now this is going to be a minus a plus or minus an e to the negative c over 2 times e to the negative t over 2. And notice what we've done here. The reason that we've done all these tricks where we separate this e into 2 parts and then switched it is because now everything that we don't know is right here. We don't know what c was, and therefore we don't know what this whole part was, and we don't know if it's plus or minus. We have to choose one or the other every single time for AP test. For the AP test. So when we go to our next step, we're going to be plugging in. I'm going to switch to green to let you know that I'm plugging in now. And by plugging in, we're going to solve for whatever this red box is. So we know that capital T is going to be 180. So capital T is 180. And I'm going to rewrite this 100 minus, and then I'm just going to say that's our box. We don't know. And that's going to be multiplied by e to the, and then lowercase t is 0, so negative 0 over 2. And notice what we have here. So negative 0 is 0, divided by 2 is 0. E to the power of 0, anything to the power of 0, is 1. Therefore, this is 1 times the box, which is just the box. And I'm left with 180 equals 100 minus box. So solving, I can subtract 100 over to get 80, then divide by negative 1. So negative 80 is equal to, come on now, is equal to our box. We have solved for this unknown box by packaging everything we don't know together. So from there, and by the way, once you substitute anything in, you could have done evaluating right here, but if you went through this work, you probably wouldn't do this step. You'd get this plus 1 at this step right here, much, much later in your work. We kind of cheat the system by evaluating when we're not really trying to solve for C. So now that I have this, I can plug this negative 80 in for this box. So this now turns into t is equal to 100, and then this is going to be minus whatever this box was negative 80. So it's going to be plus 80 now, plus 80, and then times e to the negative t over 2, e to the negative t, that t looked weird, negative t over 2. And there is our final answer. And we don't have any domain restrictions on this one. And if you do all of this extra work knowing the trick here to package all of your unknowns, then only then will you have your +1. This is going to be the second part of our fix-up. It's titled number 6, but it's really our second problem. So we're making a slope field. So let's go ahead. I always like starting at the top right. What are we doing here? This is our slope. Our slope is generated by x and y coordinates. So this, all of these x coordinates are always going to be 2. So it's going to be negative 2 over 2. So it's always going to be negative of whatever y is squared. That's kind of the trick for this little column here. So y here is 2, 2 squared is 4, and it needs to be negative, so a negative 4 slope. Oh gosh, that's going to be like a really, really steep slope, almost straight up and down because 4 is so steep. And then what do we have here? Y is 1, 1 squared is 1, so negative 1, it's just a negative 1 slope here. And when I come down here to y equals 0, that whole numerator is going to be 0, so my slope here is 0. And in fact, every time I have a y equal to 0, now that I'm noticing it, the numerator is going to be 0. So I can make all of these 0. And are there any other zeros that I can find? Oh, look, so if x is 0, if x is 0 up here, then those are 0 as well, so I can get those really quickly too. And then I just have these 4 points to do. So let's do that. So when x is now 1, it's going to be negative a half times whatever y is squared. So I can always remember negative a half times whatever this is squared. So 2 squared is 4, and then times negative a half is going to be a negative 2. So still a negative slope, not as steep as this, but steeper than this. So let's see how well I can draw that. Still has to be a little bit less steep. I think that's you have to be careful here. I think my negative 4 should have been steeper if I could have made it. Anyway, let's go to this one. So this is going to be y squared, this is going to be 1 squared, and then negative a half of that, so it's going to be negative a half slope. So it's going to be less steep than this. It's going to be like that. Trying my best. There, that looks a little bit better. And finally moving over here, so for the x coordinate here, x is always a negative 1. That means I'm really just going to be taking half of whatever y is squared. In fact, this is going to parallel this side, but by making it a negative now. So a negative slope. This was a negative 2, so I need to make a positive 2 slope. So positive 2 looks right about, that looks too close to y equals 1. Positive slope, and then this one is going to be the 1/2 slope again. So this is going to be a positive 1/2 now, like that. All right, so this problem is worth, I actually haven't looked at the solution key, the official one, but this is how I'm going to be grading it. All of the zeros, if you got all the zeros correct, give yourself 1 point. So any of these, every single one of those has to be correct, and if that is the case, give yourself a +1. And 1, 2, 3, 4, 5, 6, the rest of the 6 points, that'll also be a +1, if you're wondering. It's not super critical for the fix-up though. So moving to part B, we have line tangent. We need the entire equation, not just a slope. And it tells us where x is equal to -1. And I noticed that we are not given a y at all. Do we have y over here? Yeah, so f of -1, when I plug in that, I get y equals 2. So I can say, as a note here, y equals 2. Okay, so when we do line tangent, we need a y minus the y coordinate is equal to the slope times x minus the x coordinate. All right, so what do we already know? We already know the y coordinate is going to be, y coordinate is 2. The x coordinate is going to be -1. That means it's going to be a +1 here. And we don't know the slope, but look, it told us that dy dx was equal to this. And I just pulled this from the previous screen. I screenshotted it and put it on here. So how do I find the slope? I just plug in my x and y into here, and I find out what my slope is. So when I do that, I have dy dx, and I'm now telling everyone I'm going to sub in, and then sometimes I write x equals this, y equals this, but sometimes the quicker version is just writing -1, 2. So when I do that, I am plugging in -1, so negative is going to, well, maybe I should just write this out, -1 and then I'm plugging in a 2 squared, and all of that's going to be divided by 2. I was going to do mental math, but this is probably better. Negative 1 is a positive, so don't worry about any of that. It's irrelevant. 2 squared is 4. 4 divided by 2 is 2. So we have our slope is 2. It was only asking for the line tangent, and we have that tangent line. It is this equation. So I'm going to evaluate this one as 2 points. So I'm going to say if you're able to get the slope here, give yourself +1. If you're able to get this equation in any form, give yourself another +1. And the final part, part C, we're finding the solution. So this is the particular solution, and it gives us our initial condition. Great. All right, so we're going to go through steps 1 through 3, and step 4 is optional. That extra credit step, I will be going through that in this video if you'd like. Fraction is equal to a fraction, so we can cross multiply. We're on step 1, by the way, if you're wondering, which is to separate. Separate. You don't have to write separate on your paper if you don't want to. I'm just doing it for the video so you know what I'm doing. So this is going to be 2 dy is equal to, and then it's going to be a negative x y squared dx. You'll notice that I have a y squared on the right, but all of my y's should be on the left. So I'm going to divide both sides by y squared to get 2 divided by y squared dy, and that's going to be equal to a negative x dx. All right, so from here I need to do step 2, which is to integrate. Integrate. And when I integrate, I don't like fractions, so I anti-quotient. I bring the denominator up, and I get a 2y to the negative 2 dy. And this is going to equal the integral of negative x dx. Now I actually have to take the integral. So when I do that, y is going to go up to the negative first power, and then I divide down. So this is going to be a negative 2y to the negative 1. And that's going to equal, this is going to go up to the power of 2, so it's going to be a negative x to the power of 2, and divide down, divide by 2, that's 1/2. And don't forget your plus c, your constant of integration. All right, and then step 3 is going to be evaluate, which means plug in, and we know that our x is -1 and our y is 2, and from there I'm just plugging those in, and I'm not even going to change this form for right now. If you're just doing these first 3 steps, you don't need to deal with this. This is going to be negative 2, 2 to the negative 1 is equal to negative 1/2 negative 1 squared plus c. All right, so that is what I expect of you in the test. How many points do you get for everything if you're curious? So if you separate, you get +1 if you get to this step. If you integrate and get down to this step, that's another +1. And if you evaluate, if you plug in at all, that is another +1. And I should say +1 if you integrate, and then +1 for your constant of integration. You always get that +1 for constant of integration. How many points are we at right now? I think we're at 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep, and the last point comes if you do step 4, which is extra credit. This problem should normally be out of 8 points. So you're sticking around on the video because you want to learn how to do, or at least see how to do step 4. Let's go ahead and do that. This is going to be separate. 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 I can spell. So if I'm separating, I'm looking down here, and it's okay actually if I evaluate right away because I don't have any absolute value or anything to get rid of. And I see in the future what I'm going to eventually have is maybe a pesky x squared. I'm not sure. Let's go ahead and just find what c is and then plug it back into the equation. When I solve this one, notice that this is going to be 2 to the negative 1 is 1/2. It goes 1 over 2, and then 1/2 of 2 is just 1. So this whole thing is going to be a negative 1 is equal to, and then a negative 1 squared is a positive 1, and then multiplied by 1/2. So it's going to be negative 1/2 plus c. And therefore, we can find what our c is equal to. We need to add the 1/2 over, and I get c is equal to a negative 1/2. All right, just checking my work to make sure I didn't do anything super dumb. I have a negative 2. Yeah, that all looks correct. Now I'm going to plug my c back in to my original equation. So this guy will now become, oh, not that guy, sorry. My original equation is here. This guy becomes, I'm going to get rid of this y to the negative 1 by bringing it to the denominator. It's going to be a negative 2 over y now to make it a little bit easier to see, is equal to a negative 1/2 x squared plus, and then, well, negative 1/2. So really minus 1/2. And then I just need to solve for y. When I solve for y, I need to multiply, or actually divide both sides by -2. So when I do that, I'm left with 1 over y is equal to, divided by -2 is going to be a positive 1/4 now, x squared, and this is going to be a plus 1/4. And now I need to take the reciprocal of both sides, and I'm basically done. So when I take the reciprocal of both sides, I'm going to run out of room. I'm going to come right up here. I'm going to get y is equal to, and so this is really x squared over 4, so it's not going to be, oh sorry, everything over here is going to be divided by 1. So 1 divided by everything down there. So it's going to be x squared over 4 plus 1/4. And we do have some domain restrictions. We're not done because now we have a problem. This bottom can be equal to 0. If it is, then that's a problem. So let's go ahead and restrict the domain. If you don't restrict the domain, you do not get the points for this one. You don't get the extra credit points. So again, to make a note, what are we doing here? So this can't be 0. So let's set it equal to 0 so we know what it can't be. So when I do that, I have 1/4, I'm just factoring that out, of x squared plus 1. This cannot be equal to 0, so let's set it equal to 0. And when I solve this, I'm going to multiply both sides by 4 to get rid of it, and I get an x squared is equal to a -1, and that can't ever happen because when I square a number, it's always a positive, which means this whole thing can never be a 0. So perfect, there are no domain restrictions, and we still need to write the domain. This is part of the answer. You need this for that +1 point, but you also need for all real numbers. And that's the fancy way of writing something like this, where you can go from -infinity to +infinity. There are no domain restrictions. That's how I say it. So say something like that, and you have to say the domain is for all real numbers, just in case we had domain restrictions for that denominator. All right, and if you did all of that work, then finally you got your extra credit point. So that concludes our fix-up for AP Calculus Unit 6. I will see you guys on the test.